Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. For today's show, we've got a really exciting episode lined up. We have someone talking to us from the USA. Hopefully all the technology works out fine, but if the quality is not quite up to the usual, it's because we're going over a really, really long distance. We've got Virginia Irwin Klausmeier talking to us, and she is the founder and CEO of a really interesting company called Sylvatex. So welcome to the show, Virginia.
Ryan, thank you so much for having me. Great to be here.
And I'm really interested in the conversation today and learning more about the technology and the stuff that you're doing at Sylvatex, because that sounded so interesting when I first heard about it. But if we could start out by just finding out a bit more about you, basically, if you could tell us about your background and kind of how you got to be doing what you're doing now.
Completely, yeah. So I think I'll just start a little bit more through the journey that got me through education. So formal education was in chemistry and ended doing engineering. And my first part of my life was focused on biomechanical engineering. And I got to work for a Fortune 100 company, travel over the world, and work within a big organization. And, I think my driving theme as a human was getting more clear that I wanted to do something that was impactful to help a broader, big base of people, right? And I think I had armed myself with skills in, of course, kind of a science background, but then started to get better and understand, more around business and the economics of more broader macroeconomic trends. When I was, I'd say probably late 20s, I was really influenced by my late father, who, at the time, he had been focused on kind of clean energy and clean fuels his entire life. He had a double an MD and then a double PhD. And so he, was heavily skilled in the sciences, but not so much in business. We kind of, looking back, I realized he was kind of like he was like addicted to learning, and always was on the edge of the learning curve, which is, I think, as I sort of grow into my adulthood, pretty profound and an exciting place to be. But I think I realized as I was getting, into this career and having, quite a bit of success that, I was getting more curious about what he had been spending his time and energy on. And he had been really looking at transportation energy and, different ways to use bio-based materials and just high level green chemistry, right? At big elements so that you could really have smarter systems that were more aligned and congruent with sort of nature. And I got really inspired, I'd say, by some of that work. And unfortunately, he ended up passing away pretty abruptly from pancreatic cancer, which sadly is not uncommon these days. And for me, it was a big shift, right? So I was sort of faced with this, this human who I was very close to, who, was probably one of the most important people in my life, who was incredibly inspiring and talented. And I had I had in my own right a lot of success in the business side and, this background. And I decided to make a pretty big shift into clean energy. At that point, it was definitely founded off of some of the concept he had started with clean fuels and trying to impact sort of transportation energy in a big scale. And that started me off on my entrepreneurial efforts. And, since I founded Sylvatex, just shy of a decade ago, the intent was, how do we have better industrial applications, manufacturing techniques that really change the carbon profile and economics of transportation energy and just energy in general. And that's not kind of a small problem to set out for solving.
No, it's a big one.
It's a big one, and I think through that process, I've been able to source some great, investors, folks that have been involved in large industrial manufacturing techniques, elements like that. And I've been very, very very fortunate to have this amazing group around me. Mostly we were based in the Bay Area and over in California. And I would say, over the last probably, 6 years, our thesis has, I think in our thesis, we've really recognized the importance around EV transportation and the energy transition. And, I think for us, we started to really focus on solutions we could have in that space that could be meaningful and impactful. So we kind of went from big picture, right? Like, what does the future of the world look like in the transportation sector, and how can we influence it in a very positive way? And we landed on making EV battery materials in a way that is much more energy efficient and also much lower in cost, so that we could ultimately, make the energy transition of these batteries and make it much more effective for not only EVs, but the whole energy transition. So that's been, and I can kind of tease out a little bit more about that shorter term journey of some of the decisions we've made along the way. But in general, that's where we've been focused for the last 3 years since COVID, because COVID was another big kind of pivot point for many people on the planet. But for us, it became very clear that, when it comes to energy and transportation energy, I'd say many governments and all over the world have been doubling down on EV, and that transition really has been solidified significantly over the last, few months. So
it does feel strange and maybe somewhat validating strange in a good way. Thinking back on, 10 years ago, the kind of a lot of time was spent convincing people that electric vehicles were a good idea. In the UK, we used to get a lot of jokes about milk floats, which I don't know that translates particularly well into the US, but everyone in the UK was familiar with very slow moving, ugly vehicles that were used to deliver milk early in the morning that were powered by electric. And that's what most people thought of when they thought of an electric vehicle. So the world has changed massively in the last sort of 15 years or so. And really that accelerated massively 2016, 2017. And then the last couple of years in particular, to the point now where it's, it's almost a given, like it is happening. It is the direction. You want to decarbonize, you need to electrify to get more efficient vehicles, more choices on how you generate the fuel that they're using, the energy that they're using. So yeah, it's amazing actually what's happened there. And the context today, people listening to, well, of course it's obvious, isn't it? Well, it wasn't even fairly recently. It still wasn't. So obviously you have a chemistry background, so you are a chemist. So you're one of them. But I've got it was the science that I really didn't get on with, if I'm honest. So my engineer, I just couldn't remember all the, there's a lot of stuff to remember in chemistry. You must have had a very good memory. And you picked this sort of, it sounded like it was a deliberate sort of choice of a problem you were going to go and try and solve, rather than the other way around, where people, quite often scientists or engineers, they come up with a technology and then it kind of finds its solution, particularly in the materials space. There's a lot of, this is, graphene, it's the new best material ever. How are we going to use it? Well, we don't really know yet, but it's the new best material ever. And then they kind of work out ways. How did that happen for you? How did, was it that you thought, right, actually, with my skills as a chemist, I think we can make battery materials more accessible? Or was it that you had the kernel of I know somewhat about that particular thing and I think we could do it better? Like, how did you, was it like a brainstorming session of what are the world's biggest problems we could solve? How did that?
Super, super good question. And I feel like pretty relevant for a lot of people that are, reflecting on their lives. So there was I'd say, three different elements that tie into that. One was I was a point in my career where I had gotten a lot of exposure, right? And I was armed with sort of this chemistry and engineering background, but I had been I'd been operating more on sort of the business side. So I started to understand really what made the business part of the world tick, right? So you can have the best solution, but it doesn't, I mean, I'm sure every technical person has heard this, right? You can have the best solution, but it doesn't always win, right? It has to be marketed right. It has to be financed right. You have to have a commercial strategy, right? So there's a lot of elements that tie into it that I think was really useful for me to get exposure to. So I had that good foundation kind of at this stage in my life. And then I also was inquisitive, right? I was at a point where I was like, hey, I could either move, I saw a path moving forward in that kind of career and where that would lead. And I didn't really feel like it was enough, right? And so I was getting curious. It was brainstorming, like, what do I want for my life? How do I want things to progress? What's really keeping me up at night? What am I concerned with? And, at that point I wasn't married with children, but I definitely was, recognized that I was fearful of even getting married with children because I didn't know what the world was going to look like for the children that I was going to have in the future. Right. And so I think it was just like impending fear of just, and then sort of the element of that was, okay, well, this is like, I need to do something about this, right? Like, how do I do more? And the third sort of element that I think was, I'd say the really big pivot point was being faced with this sort of life, altering time period with my father passing away, but, and just sort of having a new, giving me a different like vigor of just being like, life is short. You need to make it impactful. But also he had invented an alternative fuel, right? So he had invented this technology, in the garage. I'd seen it over periods of time. I was helping him with his path of trying to put together a business plan when he got diagnosed and passed away. And we had done a demonstration and we saw it work, right? We saw a fuel that was low carbon, that was significantly low emissions, that could be a game changer. And, I think with that, I did have this concept of an actual technical solution that I could kind of use to go out to market with. So that helped, but from there, I think it turned out that as we started to push that into commercialization after I started Sylvatex, we did kind of move forward with fuels as kind of our first place to really have an impactful solution set. But I think, being a California-based company, we really kept on hearing, California is known now for not going to be selling any combustion engines, right? I think it's 2030. So, they've always been on the cutting edge and really towards electrification and pushing that. So, I think it really, that was right place, right time on really getting clear on what type of impact we wanted to make. So I did make sure and, do massive brainstorming sessions around the mission, the overall mission of what we wanted to do. And is this product solution fit the best to focus our time and attention on, or is there others? And then we pivoted and we had technical success in in another area that was manufacturing materials for EVs. And then we, over the course of the last few years have constantly put more and more effort. And now that's our sole focus. So, I think it is a toggle of kind of the big brainstorming sessions and having that big mission, that for me, the transition to take literally the leap of faith and jump and just try to grow my wings as I fly, was a combination of where I was in my professional career and also personal trajectory. But I think it was it was really useful for me to have something more tangible as far as like a product solution fit, and then go down the experimentation phase and really be thoughtful about, is this tackling the mission in the best way, and develop a really healthy process in that.
Yeah, cool. So there's sort of a clear, actually, you kind of started out doing something different, I guess, and then pivoted, and took the kind of skills and expertise and pivoted into something that the market and people were telling you, hey, actually what you've got, not so much, but could you do this? and you went, yeah, that's really cool. Like, I think that sort of probably took quite a long time to get from point A to point B there, but to everyone else, it appears like it happened overnight. And
completely. Yeah. And that's what I would say for, any listeners is that there is a lot of, for every entrepreneur you talk to, there is so many factors of, micro shifts that occur from learning, these are dynamic markets, right? And the more that you can have flexibility in your thinking of your product market fit and your in even what you're trying to sell or produce, it seems like the better off you are at being able to find that solution and really hit it on the nose.
Good point to talk about what the business actually does. So we know what you don't do now. You don't make alternative fuels, but tell us what it is that you do. What is the core business of Sylvatex?
Yeah, completely. So Sylvatex, or we shorten it for SVX some of the time, is future-proofing the manufacturing of the largest cost and carbon footprint driver in the lithium-ion battery, which is the cathode. So we are making that cathode material, known materials, and potentially future materials in ways that are much, much more effective for not only today, but also the future.
And is that sort of fundamental materials science, or more kind of manufacturing process technology, or tell us how you're achieving that?
Quite honestly, it's a blend of the two. So what you'll see, what we started to see as we looked at the battery space was that a lot of lithium-ion battery, materials, right? It was first, there was a lot of material innovation over the last decades. And it was always, how do we create material that can be used in these batteries in the effective ways, have longer charge times, have, just more around the performance enhancements. And now with, I'd say, the EV energy transition really starting to move pretty quickly, it's less about, the materials, I think, are more known. Like, there's more known about the material science, and people have locked into specific chemistries. And that will have sort of micro evolutions, but it's all about scale, right? How do we scale these materials that are, nano materials in ways that are much, much more efficient. So, to date, even though there is a market for cathode material for lithium-ion batteries that are high nickel or, iron based, they've been scaled for other markets that are smaller and that are much smaller market size for the, to make a battery in the EV. It has to scale up, like 100x. So the market is experiencing that massive growth. And what we do and what we focused was, even though we have an advanced manufacturing technique that is novel and it could offer probably a good platform to produce novel materials in a more effective way, we've chosen to just focus on making the known materials for the EV and energy sector now and what the market's growing in, just because there's such a huge gap and need and desire.
You make yourself? Are you doing manufacturing, in-house, or are you sort of helping the big chemical companies improve or implement processes? Where do you kind of come into that value chain?
Yeah, so we, good question. And the short answer is to be determined. Just to kind of give you some information, stats around the US market, there's the US battery market to hit the numbers of EV materials for 2030. There's been quite a bit of battery manufacturing that is, coming online in the near term, but just the cathode material production that's coming online, it satisfies 4% of that. So there's a huge gap on what's needed to supply this growing market. Well, and that's only in US, not even North America, not, in other markets, right? Yeah. So it's a massive, massive opportunity. Right now we have piloted our advanced manufacturing techniques that are a step change in cost. So they're making it so the way that we manufacture the material is dry. So we bring capex in a reduction down significantly. So the amount of capital you need up front is potentially north of 40% lower, which is significant. And then not only that, we're making it in a way that, we massively reduce the OpEx costs, and that we can make it so that you're using a broader range of input materials so that you can even further drop that cost and allow for more flexibility. So that's something that we're currently working on this scale. So we've done lab scale, of course. Pilot scale is where we're at now. We're working towards a commercial demonstration scale in the near term. And then, and just with, I'm sure you've talked about this, but there's a lot of dynamics in the marketplace where OEMs are trying to go really upstream to secure their supply. And, we're not sure if we're going to be the manufacturer to do that, or if we're going to work with a joint venture to do that, or something in between. I think there's a lot of optionality. We're trying to maintain an open, flexible front, because it does seem like there's a pretty big scramble, and flexibility is key to create the most value in the marketplace in the near term and long term.
It's not quite set, I think, with battery plants in terms of, some plants make, from pretty much raw material in to finish cells out, whereas other plants are taking in pre-processed material. So they take reels of material in, dice and slice them, and then put finished cells out. So there's kind of some variances in the market in terms of the level of verticalization from one battery plant to another, in terms of how much of the process is going on inside the battery plants. So that's a big to be decided, I think, in the industry still.
Like a lot of the active materials, so like the cathode and the anode, can't be made on site of the battery. So they're made at a different location. And what's becoming more and more of hurdles, since, I don't know the exact number off the top of my head, but somewhere, north of 90% of the materials have been made in Asian markets. As those start to be made more, a lot of the mandates in Europe and in North America are to make them more localized, right? And to make them more localized, you have to be making them in ways that are much more environmentally friendly because of just massive restrictions. And that causes a big bottleneck in where they can be actually produced in a sustainable way, right? Because the manufacturing techniques today are incredibly energy inefficient.
Just to explain that one a bit, I've talked about this and seen it. I'm no expert at all, but the conventional, so if we started there, the conventional manufacturing process, wet process for active cathode material, can you describe that? Because it's a pretty crazy process, actually, when you think about it at scale. How do people do it today?
Yeah, so and that's definitely a great place to start. So the current process is called co-precipitation, and it uses, first off, you take all of the transitional metals, so like the nickel, the cobalt, not like the lithiums are usually lithium hydroxide, but most of the metals have a sulfate on them. So that's a big portion of the molecule that's being shipped and transported. And then you have a huge tank where you have initially all of the metal inputs going in and dissolving. So the sulfate helps them all dissolve. And then those all combine and come together. And then you separate and dry that out. And then you add in the lithium as a second step. And then you take that and calcine it, or put it in a big heater at really high temperatures that makes them into nice small particles and burns off all the other contaminants that could be in the battery. So then after that, you have a powder, black powder, that's a cathode material that can either be you can coat that or do something else. There's other sort of items that can happen after that process for performance enhancements, but most of it is most of the process is actually just the manufacturing process. And in that, the reason I mentioned the sulfate material is that it requires a huge amount of water, right? So you have, like, if you look at a tank, 80% of what's 60 to 80% of what's in the tank is not going to come out. So the yield's really low. It's waste contaminants. It's waste material that either has to get dealt with, right? You either have to manage the sulfuric acid that comes off the side of it, and water, and manage that wastewater streams, which is challenging in different environmental markets that have more constraints, right? Which are probably better for the planet. Well, they are better for the planet. That's not a probably. I'm just trying to be kind and diplomatic.
So that initial part of the process there for the active cathode material, where you're going from sort of raw inputs to a powder that's ready to go into the coating process, that part of the process is, you're turning out tens of, it's not making 1 or 2 kilos of material. This is like serious scale tonnage needed for battery production, and you're doing that on a batch to batch basis, isn't it? It's not a continuous process.
It is a continuous process in that, I think in more of the larger shops, but to your point, the volumes are massively increasing, right? So again, this was a process and, that was designed for manufacturing these high-end materials, high value materials at a smaller scale for cell phones. And now they're trying to really expand the scale so significantly. And so you have a lot of different lines, right? But the limiting factor is you're using a huge amount of water and waste kind of in it. So your yield of what you put in is so much smaller from what you get out, right? So there's a lot of, just generally from high level, it's inefficient. And then you have a huge amount of water that gets used in the process. So that's, having high grade water and all of that is a limiting factor, I think, across the board for battery manufacturing. But really it's highlighted in cathode manufacturing. When you're looking at the battery pack itself, about 50% of the energy or carbon that it takes to make the battery pack, when you look at the full carbon intensity or carbon life cycle, about half of that is from cathode material alone. So it's for being a relatively small amount of material, it's a huge part of the carbon profile, and also cost. I mean, just to sort of add that in on the cost profile today, it's about, maybe even up to 70%, but mostly around 60% of the battery pack is just the cathode material. So it's it's a high cost, it's the biggest bottleneck of everything, right? And the general sentiment is of the industry growing and expanding. It's the biggest bottleneck by far, and we're not making barely enough of it, to hit, near-term goals.
Interesting that the manufacturing capacity is one thing, obviously, but what really interests me there, gets me excited about what you're saying is that obviously a lot of people love to have a go at EVs, the high cost of the vehicle, that's one thing, but the input CO2 being higher than it is with a combustion vehicle. So that's got a lot better over the last couple of years. So anyone looking at 3 or 4 year old figures will get a surprise if they when they look at things for new vehicles, because we gain manufacturing efficiencies all the time to reduce the CO2. But then such a huge number coming from active cathode material, so 50% of the pack. That's going to be a huge proportion of the overall vehicle CO2. And basically what you're saying is, hey, there's a huge amount that we could take out of that. So it's not that that's fixed and there's nothing that we could do to make that better. You're actually saying we could make that loads better. Bring it on.
Yeah, we can make that loads better. It literally, you can make that loads better from a cost profile, massively change the cost dynamics to bring the cost of cathode material significantly down, which would bring the battery pack significantly down. And then thus, hopefully that translates to the EV, but who knows who's going to capture that value. But the other side of it is when you're looking just at trying to retain, carbon efficiency, is a lot of it can be done on the manufacturing standpoint. So, the thing that's interesting about where we are in the world right now is there's such a dynamic around scale, fast, right? The scale, even at the scale that it's, the same type of manufacturing techniques just expanded coming online. One, it doesn't meet carbon neutral benefits the OEMs have set for themselves, right? So it doesn't get the industry to the carbon zero goal, right? And what we kind of design, what we focused on design was, okay, what would, right? You need to do something different, and you need to do something that is making these new materials, because if you change any of the materials in the battery, then it goes through a whole different life cycle of, coming a path to market, which is just challenging to predict and manage. So we didn't want to kind of play that risk profile game. But we can do, we can add a huge amount of value with just staying focused on increased manufacturing techniques and being able to do it in a way that is really thoughtful and forward looking, that not only drives the economics, opens up optionality for the future, but also massively reduces the carbon profile and waste, so that it could not only be made, be able to be permitted in places like Europe and in the US, but also can ultimately help with curb the carbon, the global emissions, which is the ultimate goal.
One topic I was talking about in a recent podcast episode was to do with the sort of changing chemistries in battery, and you just touched on this, but a lot of the high performance packs, they are NMC, obviously a bit of sort of an effort to try and get rid of the cobalt because of the cost of that, plus the actual literal economic cost, plus the sort of social costs of acquiring cobalt. But then we got onto this sort of resurgence in lithium ion, LiFePO4 batteries. So to be honest, when I first came across years ago, I didn't think they were going to be suitable for use in vehicles, but now actually they've improved to the extent where they are, and the vehicles can deal with it. So I guess the question is, your process, are you kind of agnostic to all of that, or are you kind of also facilitating, I don't know, like the transition from cobalt-based to cobalt-free, or do you not see that really in the kind of work you're doing?
So short answer is all of the above. So we are agnostic to the chemistry. We're designing the process so that it can go across the trends. One of the things that we saw that was really interesting, was that most of these manufacturing methods, they're really sensitive to the chemistry that's being made. So if you change chemistries, or if those markets change dramatically, you can't utilize the same asset in a most of the time at all, but definitely there'd be a lot of change that needs to happen. So we definitely are designing the process to be able to be chemistry agnostic. With that said, we are focused on the sort of high nickel, low cobalt materials, so like the NMC 811, et cetera, for the market in the near term. And just because that, I think that there's a lot of opportunity to use recycled materials as a lot of these battery manufacturing plants come online, and then there's waste, and there's just a lot more opportunity there to satisfy the market, and also do it in a way that really can curb the carbon and cost profiles. But the industry, I just came from an industry conference, and there is definitely LFP is definitely going to be in the mix, in the short and long term. The thing that's interesting though is LFP mostly was being a driver because of cost. And just because the price of lithium has been so high, it's such a big portion of the lithium price is in LFP. It actually was higher in cost than NMC. So I think that, exactly, right. You laugh, and it's like, these poor OEMs or, automotive OEMs are trying to figure out, well, how do we,
it's like a game of pinball.
It's so sad. So, I think that, I think what I'm hearing by and large is, one, you need to have the ability to kind of toggle, right? You need to have more flexibility. You need to have the ability to toggle, and you need to go down, go more higher upstream to secure your price and secure your materials in a more healthy way. And I think for us, that's kind of what we are hearing, and we think is a great healthy path forward.
Before I jump into some other questions, because I've written down about 6 there. It's like, I want to know. But, be a good, you sort of told us the way that it's currently done. So this wet process. So tell us about your technology. What is it that you guys have come up with?
Yeah, definitely. So we have targeted away. We sort of looked to the future and designed backwards and said, okay, we're used to designing for and focusing on big industrial applications and manufacturing techniques to do, that utilize green chemistry in a way that's really effective. And what we saw in the future was, one, we needed to design a process that was the most efficient possible so that you could get to the carbon, zero goals, and empower the industry to hit those. Because there's no way that can happen if you're not targeting advanced manufacturing techniques in cathode, right? That's like a 0% probability. So that's where we focused. And to do that, you need to have a process that's dry, that's really energy efficient. So that means that you're bringing these nanomaterials, these metals together in a very efficient process. So that's usually using smart green chemistry practices and some material science, et cetera, right? So I think that really played on our experience of doing nanomaterial synthesis and being able to, blend that in with green chemistry practices. So, we focus on using an organic material that brings inorganics together. So that means something that's carbon-based and is bio-based, et cetera, natural, that can bring these molecules together, the metals, transition metals in a very effective way. And we do that without using water.
Just rewind a little bit. Nanomaterial synthesis. What's that?
Yeah, right. Very, very small things coming together. No, but it is when you're, building very fine materials from the ground up. So one of the things that's important for not only cathode material, but a lot of nanomaterials is you're really having building blocks where you have layers, right? So you have like the nickel, and then you have the lithium, material. And so that the electrons can sort of be more efficiently passed through. So you're really building these materials from at a nanoscale up. And to do that, you have to do that well, so they perform well. You have to have smart synthesis techniques that build the molecules together in an efficient way. But nanomaterial synthesis, it sounds like a lot of jargon, but if you just think about the smallest things that you can get down to, like the electron level, like this, a particle of metal, is you're just being thoughtful about putting them together, the architecture of building them in an effective way. And we use natural based material that helps to bring those molecules in a way that helps to bind them together, kind of like you would have, like an egg in a recipe. That's probably a really bad example. I need to think of a better one.
I heard people talk about scaffolds before when they're talking about nanomaterial constructs. Is this what we're talking about here? Scaffolds?
Yeah, kind of. It's helping to create the architecture in an effective way, and then they can combine and come together, and then you just pretty much burn them into that molecule, right, and burn off all the other materials.
I still don't understand, but that's because I'm not a chemist.
Yeah, it is like scaffolding. It is like scaffolding. Yeah, it is. It is.
There's a reason why I didn't enjoy chemistry. Okay, so it's kind of talking really fundamental change in terms of how you're coming up to the final cathode material, but something that I would imagine, is it easier to control that sort of process or get to a consistent result? Your new technique compared to the traditional methods?
Great question. I think like the jury's still out. We know that we can control the process, and we know we can get continuous good material out. So we know both of those are true. We do believe that it is going to offer more, I'd say more optionality, because you just are doing more direct synthesis support, right? So it seems to all be along that trend, but yeah, I think that we'll have substantial proof in the near term that that's true.
And I've heard people talking about where they're using a process like plasma, basically, to create the nanoparticles. At a small scale, it's a really effective process, but it doesn't scale up particularly well, because you've got to pull a vacuum down, and there's all sorts of process technical constraints, purities, and all sorts of things going on where you can make a small batch really well, but then to make a big batch, it just doesn't work. Will you have those kind of things to overcome, or do you think you're
great? I love that question because I think it goes back to your framing of, did you have a technology you're trying to apply into a market, or did you design a solution for a specific market need? And I think, we did the latter, right? Where there's only, like, I'd say a few other techniques that are kind of out there that are trying to tackle innovative approaches. And most of them have had technologies that have been used in different areas, but they're applying it to this market at massive scale, right? We kind of did the opposite. We said, okay, what do we know about big industrial manufacturing techniques? Because we, kind of came from fuels, which is the largest volume of, chemical manufacturing by far and large, right? So these volumes are significant, and we applied that type of thinking into making these nanomaterials. So I think it's been very different. We've always addressed it on a technical standpoint of what can be done at scale, and then how do we prove that out from going from small scale to larger scale. So I think we're fairly confident that our advanced manufacturing process can be scaled quite efficiently for sort of two reasons. One is we're not trying to make novel materials, so we can constantly confirm sort of the quality at a continuous scale basis. But then also we are the actual engineering piece of it is using kind of equipment and techniques that have been used across different industries for a period of time, right? So we're not making like a high grade plasma engineering heavy thing that we have to make from small scale to large scale. And then also at the same time, I mean, it's just me, but that doesn't sound very energy efficient. So, we kind of said, okay, what's been out there? What are elements that can be working to come together and kind of stitch together a more effective solution for this specific scale need, for this specific market application.
Can you tell us anything more about the sort of magic, or is that kind of, I appreciate there was certain, they might not be able to tell us too much in terms of, trade secrets and IP sort of things, but how much can you tell us about what you're doing in that process?
Yeah, I mean, I can't, a big portion of it is proprietary, but the big thing is that the big thing on the front end is that of the process is that we can use just the pure, the metals in the oxide form. So we don't have to have the sulfite molecule, which makes using recycled material much more effective, and also just more efficient mined material and processed material. So it really cuts down upstream manufacturing costs and carbon expenses. And then the other side of that too is that we have it all done in a single pot. So we can add the lithium in all together. So it's a single pot process that is dry. So it's not in an aqueous solution where we're combining a bunch of materials to help with making it, we use a small amount, like a trace amount of a solvent material that can be easily burned off. So that's something that, has been in the design, again, thinking about big industrial scale, and is primed for us to be really competitive on a cost standpoint, but also creates a lot of optionality in the future for hedges in sort of mining or cost of material goods, right? So you can much more efficiently hedge for the different nickel or lithium or, blends of chemistries.
You talked about the 50%, so the active cathode being 50% approximately of the battery pack. In terms of the cost and CO2 contribution, what do you think there is in a potential saving in that? Where do you see that getting to with new processing technology like yours? Is it, you're taking 10% out or like 60% out of that 50%?
Of the 50%. So from an energy standpoint, from sort of the carbon standpoint, we think we can take away half of the current carbon footprint, as we progress, not only from sort of the processing side, but if we also work on upstream optimization, we could, that might even increase. So it's significant, right? And then the other piece of it is that, we can imagine right now that we can slash, the cost of the battery pack at least around 15%, which is, mind-boggling, given that and it probably can even be north of that, depending on, again, sort of some of the upstream optimization and the dynamics, like controlling dynamics in that market space. So that's game changing for sort of, if that translates to the cost of a vehicle, right? So one thing that's kind of interesting that we see as far as a correlation is if you bring the cost of the battery pack of an EV down 1%, that equates out to a 3% increase in EV sales. So if we, think that we can do it, 10, 15% or even more, that's about like an increase of sales, like 45%, right? So you're just driving the cost down, make it more efficient, making them more readily available. So there's a lot of elements that trickle down as shared benefits on the cost side. But then, of course, what drives us is that we're, allowing this marketplace to really unlock in a way that is the most carbon efficient to ultimately get the global carbon needs down in a very effective way. So you're not just sort of trading one problem child for another.
Yeah. It's what's so exciting about this, this sort of period in time. It's not just you guys are working on really exciting technology there with a huge potential benefit, but there's a number of things all going on at the moment where you really can we're starting to see that cost trajectory of an EV falling quite significantly over the next 10 years to the point where the market's just going to decide. So the investment that's going in and the performance benefits and sort of leaps forward in cost reduction and things that are coming out, like, because at the moment the discussion with people is it's a difficult one in terms of buying an EV because it's more upfront investment and total cost of ownership, and you kind of legislation driving it, but actually we're not that far away with everything that's coming where it'd just be like a no-brainer.
Yeah, it's pretty close to becoming a no-brainer, but there's still like there's a learning curve, and there's because there's like different math you have to do, right? Because I don't think that people today factor in the price of running their vehicle. It's like the price of the car up front, but then you don't kind of factor in the price of running that vehicle where, I think that's very different math. So that, that is like a little bit of learning, and the costs are coming down. So I think both of those are definitely trending in the right direction. And I think the other side of the curve is making sure that the markets have the materials to perform and produce what the growing demand. And, I think that that's what's keeping me up at night. And, quite honestly, there's enough sunshine to shine on all of the solutions out there, but we need to really be thinking about scale, fast, bigger, more, right? So all of your, I just came back from this conference, and the sort of key theme was like every assumption you're making, just like double it or 4x it to even, help out the marketplace. And every one of us needs to continuously win and support each other. So it's not as much a competition as it is about growing together for a big problem solution.
It's not just electrification in automotive either. Electrification of cars, all forms of transport, from cars to ships to planes. It's really the electrification of everything. Plus, add a big dollop of stationary grid storage on the side, and actually, energy storage is such an important thing in the coming years to allow us to manage demand and production of energy from different sources much more effectively. It just, the ability to store energy really is, that is a key transformational topic in so many different fields. Things like why you can't have good mobile robots today that do a proper job. Well, a lot of that's driven by battery system cost and functionality. That's why all the when you see them demonstrating the advanced robotic systems, quite often they've got a tether on the robot still, but it's because it needs to get its energy from something that isn't the battery pack.
Kills that type of innovation value. But, I think what you're saying is like, it's kind of like building a website without the internet.
Yeah, exactly. Yeah. And there's so many fields where energy storage, battery energy storage are, is already making a huge impact, but you can just see it won't take much more that the market needs it, but also the technology is evolving to a point where it's kind of like this win-win situation of the more the technology evolves, the more new opportunities come through in addition to the already big opportunities. So when just your comment about whatever you think, double it. I can see that in automotive, but I think some people still aren't looking wide enough beyond that to other kind of new opportunities that are coming along, and be that as boring in inverted commas as grid storage, or as exciting in inverted commas as robots and flying stuff. It's just, there's so much going on at the moment, and batteries are at the heart of it. Motors and drives as well, but battery systems are at the heart of it. This question is kind of I think I might know the answer to this already before I start, but the other part of the process, so when you're making a battery, you've got your cathode material coming in, your active cathode material. So it's quite interesting, your description of the traditional process, which was a wet process, and then it makes a powder. Because then when you take that powder into the battery plant, there is the coating process, which is another wet process again at the moment. But there's been people playing around with dry coating technology. And I was wondering if you had, how does your technology fit in with sort of dry coating? Is that something you see coming? Or because again, that's another huge step, taking solvents out, that drying process out, making it possible to process.
Yeah, that's part of, and that's mostly done at the battery, like at building the battery pack cell, piece of the puzzle, which is downstream of us. So it's all additive, right? So that innovation is absolutely necessary to, again, create a solution that drives down the carbon emissions of the overall battery pack, and also the cost. But it's completely additive to all of the innovations that we're developing and focused on.
Yeah. Okay, cool. So you wouldn't, and it's not something that's like, oh, well, you couldn't do that if you're using our technology.
Nope, not at all. Yep. And that's the thing that's so I would say, beautiful about kind of just generally this space, is because we are working upstream. I mean, there's a lot of work and support on trying to make just battery pack efficiencies much more, like lower those cost profiles, lower those carbon profiles. And that's been, and also scale them in an effective way, right? So you're seeing all these gigafactories come online. It's great. They're becoming more and more efficient as that continues going on. I think the next, where you're starting to see a little bit more emphasis of the market now, is everyone's going, oh, that's great. And whoa, this is now the biggest bottleneck by far, right? So you have to then look further upstream and say it's the active material. It's either getting your hands on the anode material, or, even producing and making the active material, which is like, it is now turning into the biggest bottleneck. So they all are additive and important to continue to move forward. So I definitely think of, I definitely try to work with a lot of those colleagues in the supply chain and talk to them about what's worked and what hasn't, and, learn from them, because I think it's so important that we scale and grow fast all together.
Interesting. It's going to be, I think that, because there was a lot of talk around Tesla doing dry production, but it kind of went quiet. They acquired a company that had sort of made that technique for making supercapacitors, and there's a bit of talk at the time, and then I think Tesla came out with some sort of comments about it in the future, and then it sort of all went very quiet, and we haven't really heard anything since about it, which would be interesting to know if it is something that's still on their kind of roadmap, or if they maybe tried and hadn't. But I know other companies who are looking at that sort of dry coating processes as well, because it just seems to bring so many benefits from a cost process point of view.
And not to further emphasize it, but just from the benefits on the cost and carbon side, it's like a fraction of what addressing the cathode market does. So it's a solvable solution, and that's important that the markets have been looking at it. but, I think it's been closer to battery manufacturing. So you are seeing, as there's been an emphasis of more gigafactories, there's more of an emphasis of tackling the problem within gigafactories, but then outside of that is actually like getting the active material in, right? So it's again, a really important point. And and you are going to see, it's definitely not going to disappear. It's just a matter of implementation and then scaling it, making it be effective and productive to get the results. But, so which is time and energy and money, but so it's not going to disappear. But it is like I think what happened for me is as I started to see these things in mainstream communications, right, in the industry, and then I started to see how I bench them against what it means for sort of cathode carbon or, affecting the manufacturing process over here. It's literally a fraction, right? So I think the dry anode process is like just the dry electrode process. It's something like 10% of the carbon profile of the battery. So it's a big piece of it, but spot wise, it's, not as much at all. So that's what surprised me as I started to dive in a bit more.
I wouldn't have guessed that actually. I learned something there, so I would have had it at a bigger number. But that's that's interesting. So it really is the downstream process that's driving that energy content. So the next question, and I couldn't really do an episode about battery technology without asking this question. And some people literally would hold their head in their hands and shake their head at me when I ask it. But solid state technology, ? That's often talked about as being the next kind of new dawn in battery technology is solid state. There's various companies working on it, people claiming to be near production, not so much with the large format cells for EVs, but definitely people making small scale cells and planning the larger ones. How would that impact upon what you're doing? Do you have a part to play there, or is that going to be a massive disruption?
Yeah, great question. So when you look at the battery cell, I'm just going to kind of break it down. You have the anode material, the electrolyte, and then the cathode material. For solid state, most of the innovations are around anode and the electrolyte material. So I'm not going to say all because there's a huge amount of development in the space, but from looking at the cost of the packs of solid state, you're still using the same amount of cathode material. You might end up using a little bit lower amount, but not a huge amount lower. So the market's only going to increase as solid state comes online. And it looks like it's going to be more towards nickel, nickel heavy materials. So, you're seeing a broader emphasis on the nickel there for solid state because you can't get around that for the performance. And also the volumes are going to either maintain the same level of growth or even go higher with sort of solid state picking up, and expanding the market in a newer way. So it's for cathode, it only enhances or, grows the market, but for anode materials, you'll see a different blend of what's being used, right? So it's not going to be like graphene, it's going to be like silicon anode or, other materials. And then it definitely changes the sort of electrolyte.
That's, so you've got, quite a long path.
Oh yeah. The road is long and massive. It is not, there is nothing in sight that can disrupt that.
You've thought this through, haven't you? You've thought this through.
Yeah, right. Yeah, big problems. That's what we like to solve. Big, large, growing problems.
Looking forwards, and this could be a company thing or an industry thing, but what are you most excited about, that's going to happen in the next year or two?
Oh man, I'm excited. One, I'm excited about the emphasis that I think is really real around carbon intensity and an environmentally effective manufacturing process of unlocking, the battery space. So that's been an exciting trend. Of course, recycling is an element of that, but it's kind of like I think the market in general is trying to figure out how it's going to how it's going to grow in an energy efficient way. And I love that emphasis. And I think we're going to see more and more of that. So I think the industry is really growing on how to talk about it and how to have apples to apples comparisons, right? So there's going to be a lot more sophistication within the language of how to do things well, which, is going to be exciting for us. And I think the other piece that's really exciting that I think is connected to that is there's a flurry of activity, and I've been very excited to see the openness and the rate at which sort of automotive OEMs and different large chemical cell manufacturers are learning and recognizing the space for parties like us that are innovating in a specific area, and how important it is for us to do that innovation that then they can adopt, right? And be worked into their innovation cycles. Because all of these markets are so bogged down by just scale and change, right? And so I think that it's turning into a really nice role for innovators that are kind of coming in sort of on the startup side, kind of innovating in tandem and parallel, and really having a huge amount of collaboration. So, I was talking to some folks recently, and, people were noting that it hasn't been as typical to see huge amounts of innovation and collaboration in a space. Like if, at a battery conference, everyone's talking about how they can support each other and grow and what learnings they can, learn with and expand and scale faster. Where, if you were at like an oil conference, how many years ago, even today, it's just all closed door strategy, right? And it's, it's not the same, right? So
it's the evil empire.
Yeah, exactly. Just build your empire, your empire in like a silo, and and that's not the same as this industry. And that's really exciting. It's where I love to shine. I love collaboration, and I really don't want to, if there's anyone that can do what we can, like parts of what we do better, love to work with them and focus on what we can do in the best way.
Here's a question to end on. One of the things, in the industry, and I think you touched on it a little bit there, but just to expand on that a little bit, an OEM or a tier one supplier, tier two supplier looking, this is the core of their product. This is like, you've got to have your battery cells and supply chain under control for your battery pack, and have a really clear strategy and have some, be doing some things to explore new tech, but it's such a, this is the heart of the product. If you get it wrong, you're in, in the up the creek without a paddle, we might say, to try and not put a rude word in the podcast again, like I did last time. I am going somewhere with this, I promise. You're a small company at the moment. Do you think that the climate at the moment is such that it's possible for the larger companies to take a risk with a smaller company because they're so sort of keen and desperate's not quite the right word, but they're seeking out ways to make all of this make sense, that they're willing to take a risk? Or is that still a really big barrier to get someone to trust you to make their material? So do you see larger companies being prepared to take technology risk on smaller companies, particularly your company, in the space that you're in right now?
I mean, short answer is yes, because I think they know they have to, right? It's the literally there's not a way to make battery materials that are net zero with anything in the pipeline of conventional. So you can't just only adopt what's been done at small scale for cell phones and extract that into the EV battery space, because the market and the market focus has been to make these materials in a net zero way, right? So I think that just that alone is kind of daunting, and they know that they have to adopt new, right? And I think the other piece of it, which we try to make easy for parties we're talking to, and we're early on this. We have a lot of, we've had a lot of mentors and advisors in the space, but we just came out of stealth mode. So the industry partners we've been working with have been really receptive. But generally, these investments in making like an existing cathode manufacturing plant is 350 million, 450 million CapEx install, not to mention the operating costs. These are like $1 billion projects, right? Why wouldn't you put like 10, 20, 50, even 100 million over here to see if that works to save you billions of dollars in literally the next 5 to 10 years? It would be silly. Like, I mean, from an executive standpoint, it's kind of like, who's the silly person that doesn't sign on to planting some of those optionality seeds? Because one, we know that investment in the future, the same as, conventional methods, are not going to get us to where the future needs to go. And the investments into novel solutions is so much lower in sort of a CapEx extended, if you just do the math, that even if you, don't knock it out of the park right away, even if you have a slow rate of progression, you still save billions and billions of dollars, So not to mention the competitive edge and all the things.
The risk of not doing something is much bigger than the risk of doing something.
Completely. And it's so good. Like, what I'm excited by is that it's so obvious right now, right? It's so obvious, even at the government level. The risk of not doing something, right? Not doubling down, not putting a bunch of investment in building out this infrastructure is so high that everyone is, you have to move. So I think it's the same type of mentality that is painful. And, people have had to learn it's not what comes naturally, right? I think everyone doesn't like change. So at a visceral level, but I think now it's actually the risk of not changing is so much greater. And that type of mentality is starting to gain a lot of traction.
Well, thank you so much for that. It's been really interesting to learn more about what you're doing and the potential of it as well. I mean, that's fascinating. But thanks for taking the time out to talk to me today. That's been fantastic. Thanks, Virginia.
Completely. Yeah, my pleasure. And have a wonderful rest of your week.